Guys, I welcome you all to Engineers Academy. Do subscribe my channel if you haven't done it yet. Now we are going to solve this one another problem from chapter 15, Hibbeler Dynamics. And the problem says that the towing force acting on the 400 kg safe varies as shown on the graph. Determine its speed starting from rest when t equals to 8 seconds. How far has it traveled during this time? So we have to find the velocity when t equals to 8 seconds, and we have to find the distance traveled after t equals to 8 seconds. So now for that we have to apply the principle of linear momentum, which says that the initial momentum plus the impulse due to the external forces will be equal to the final momentum, and let's say that the final velocity is v. So the initial for now we can say that the force we can see that the force is given as a function of time, and we have two intervals from t equals to 0 to 5 seconds. So between t equals to 0 to 5 seconds the force is linear, but the slope of the line is different from that of the other line, which is from t equals to 5 to 8 seconds. So we have to apply this principle of linear momentum equation for t equals to 0 to 5 seconds, and then from 5 to 8 seconds. So since from 0 to 5 seconds and from 5 to 8 seconds f is a function of t, and that is the straight line, so we have to find the straight line equation from 0 to 5 seconds. So for that we have to consider a point on the graph. Let's say that on the graph we have some point here, and at this particular instant the value of the force is, let's say, f, and this is at some time t. So now we have two triangles. We have this triangle, this large triangle, and then we have this small triangle. So the ratios of the corresponding sides of these two triangles will be similar, since both of these triangles are similar triangles. So we can say that the perpendicular of this triangle will be equal to this f minus 0. So let me write that the perpendicular, or we can say that f minus 0, this distance is f minus 0, and this is the base of this triangle is t minus 0, right? So the perpendicular is f minus 0 and the base is t minus 0. So this will be equal to this perpendicular of the larger triangle divided by the base of the larger triangle, since both of these triangles are similar triangles. So we can say that this height will be 600 minus 0. This will be 600 minus 0. So I will write that this is 600 minus 0 divided by the base of this triangle, which is 5 minus 0. So this is 5 minus 0. So we can say that this is 600 divided by 600 minus 0 is 600 divided by 5, and 600 divided by 5 will give us 120. So this is 120, and this will be f minus 0, so f divided by t, and from this equation we can write that f is equal to 120 t. So this is f is equal to 120 t. So this is the force equation for the interval when t is greater than 0 and less than 5 seconds. Now we can repeat the same procedure for the second interval. Now for the second interval, let's say that we take some point here. So here let's say that the force value is f, and again at some t value, let's say somewhere here is t value. So again we have two triangles, one large triangle and one small triangle, like this. So for small triangle, let's say that we have this small triangle. So the perpendicular of this triangle will be f, this will be f minus 600, right? So that height is f minus 600 divided by the base. So this is the base, and this base is t minus 5. This is t minus 5. So we have to divide it by t minus 5, and this will be equal to the height of the large triangle. So let's draw that large triangle. We have this large triangle. So this height will be 750 minus 600. This is 750 minus 600. So 750 minus 600 is 150 divided by this base. So this base is 8 minus 5, so that is 3 seconds. And 150 divided by 3 is 50. So now from this equation we can write that f minus 600 is equal to 50 into t minus 5. If we multiply both sides of equation by t minus 5, so we will have the equation like this. So this will be f, and this will be 50 into t is 50t, minus 50 into 5 is 250, and this 600 will come on the other side of equation, so it will become plus. So this will be 50t, and minus 250 plus 600 gives us 350. So this is plus 350. So this is the f of t function for the interval when t is greater than 5 seconds and less than 8 seconds, or less than equal to 8 seconds, right? We can say it like this. So now we have the force equations for both the intervals. Now we can apply this principle of linear momentum. So now for t greater than 0 and less than 5 seconds, v1 is 0, the initial velocity is 0 when t is equal to 0. So when v1 is equal to 0, this will become 0. So we are left with this equation f dt. So we are left with this equation, and now we know that f is, for this interval, f is this, f is 120t. So I will write that this is f is 120t dt equals to mass. So mass is 400 and velocity is unknown. So we can write this 120 outside of integration. This is, and then if we integrate this, so this will be 120t squared divided by 2, and the integration will be from 0 to t, right? So this is from 0 to t equals to 400 and 120 divided by 2. 120 divided by 2 is 60. So this is 60, and this is v. So now from this we can write that v is 60 t squared divided by 400. So 60 divided by 400, this gives us 0.15 t square, 0.15 t square. So this is the velocity equation. We can write that velocity is 0.15 t square for this same interval. Now if you want to find the velocity when t equals to 5 seconds, we can find the velocity value. So I have to put t equals to 5 seconds in this equation. So 0.15 into 5 square. So 0.15 into 5 square is 25. So this gives us the velocity equals to, this is 0.15 into 25. So this is 3.75. So the velocity is 3.75 meter per second when t equals to 5 seconds. And now since in the problem statement it is said that how far it traveled during this time, so from this equation we can find s of t function, right? So we know that velocity is ds by dt, and this is equal to 0.15 t square, and if we multiply both sides of equation by dt, so we will have ds equals to 0.15 t square. And to find the s of t function we have to integrate this. So we have to integrate this, and this will be from 0 to s, and this will be from 0 to t. So now when we integrate this, d will cancel out and we will have s minus 0, and this will be 0.15 t to the power 3 divided by 3, and this is from 0 to t. And if we put these limits, we will be left with this same equation. So now s is equal to 0.15 divided by 3 into t cube. So this gives us s equals to 0.05 t cube. Now if you want to find the distance traveled in the first 5 seconds, so we have to put t equals to 5 seconds in this equation. So that will be s equals to 0.05 into 5 to the power 3. So 0.05 into 5 to the power 3 gives us 6.25 meters. 6.25 meters. So for the first interval between t equals to 0 to 5 seconds, the safe travels 6.25 meters distance. For the second interval, when t is greater than 5 seconds and less than 8 seconds, we have f as a function of t in this equation. So let me write that f is equal to 50t plus 350, and when t is equal to 5 seconds, s is equal to 6.25 meters. We have just determined that, and the velocity is 3.75 meter per second. We have just determined the velocity, which is 3.75 meter per second. So now again we have to apply the principle of linear momentum, and the principle of linear momentum says that now mv, let's say that now when t is equal to 5 seconds, let's say the velocity is v. We have determined that, let's say that this velocity is now v1. When t is equal to 5 seconds, let's say this is v1 for the second interval. So for the second interval, v1 is the velocity when t equals to 5 seconds. So this is mv1 plus the impulse, which is f dt, and equals to mass times v. So let's say now the final velocity for the second interval is v, and the initial velocity for the second interval is v1, and we know that v1 is, now this v1 is known, which is 3.75. so now mass is 400, v1 is 3.75. we have determined this, and the plus the integral, and now f is a function of time. This is f as a function of time, which is 50t plus 350 into dt, and this is equal to mass is 400 into v. So this is 400 into 3.75. this gives me 1500 plus, and now we have to integrate this, and now this is for the interval from 5 to t, let's say. So we have to integrate this from 5 to t, and now when I integrate this, so this will give me 1500 plus the integration of this will be 50t square divided by 2 plus 350t, and we have to put those limits from t equals to 5 to t equals to t, and this will be equal to 400 v. So this is 1500 plus, we have to put these limits, so that will be 50 divided by 2 is 25. So 25 t square plus 350t minus, now we have to put that 5 value, so this is again 25. 50 divided by 2 is 25 into 5 square plus 350 into 5 equals to 400. Now we have to find this value. This gives me 2375. So now we can write this equation as 1500 plus 25t square plus 350t minus, and this comes out to be 2375 equals to 400. Now we can add both of these, so 1500 minus 2375, this gives us minus 875. so this equation is 25t square plus 350t, and this will be minus 875, and this is equal to 400 v. This is 400 v, remember. So now if we divide both sides of equation by 400, so that will be 25 divided by 400. This is 350 divided by 400. So we will be left with the velocity equation for the second interval. Now 25 divided by 400 is 0.0625. This is 0.0625 t square plus 350 divided by 400. This is 0.875 t minus 875 divided by 400. This gives us 2.1875. This is 2.19 approximately, and this is equal to v. So now this is the velocity equation for the second interval. So let me write that this is v equals to this for the second interval, that is t greater than 5 seconds and less than 8 seconds. Now in the problem statement we were asked to find the velocity value in t equals to 8 seconds. So we can find the velocity value in t equals to 8 seconds. We have to put that value in this equation. So let me write it here. This is this will be v equals to 0.0625 into 8 square plus 0.875 into 8 minus 2.19. So the velocity comes out to be 8.81. The velocity is 8.81 meter per second at t equals to 8 seconds. So this is that velocity which was required. Now in the problem statement it was required to determine the distance traveled. How far has it traveled during this 8-second time? So now we have to find s of t equation from using this velocity equation. So now we know that velocity is ds by dt equals to that same equation, 0.0625 t square plus 0.875 t minus 2.19, and if you multiply both sides of equation by dt, so you will have ds equals to this. And similarly, we need to integrate this in order to get the s of t equation. So we have to integrate this, and now the integration will be from t equals to 5 to t, and at t equals to 5 seconds the s value is 6.25 meters. So this is 6.25 meters. So we have to integrate this from s equals to 6.25 to s. So now when we integrate this, so this will cancel out and we will get s minus 6.25. This will be equal to, and now if I integrate this, so this integration will be 0.0625 t to the power 3 divided by 3 plus 0.875 t square divided by 2 minus 2.19 t, and this is from t equals to 5 until t. So this is s minus 6.25 . So now if we put these limits in this equation, so that is s minus 6.25, this is equal to 0.0208 t to the power 3 plus 0.4375 t square minus 2.19 into t, and then minus 0.0208 into 5 to the power 3 plus 0.4375 5 square minus 2.19 into 5. So this gives me 2.5875. And now if I bring this minus 6.25 to the other side of equation, so it will become plus, right? Let me write this equation as s equals to 0.0208 t to the power 3 plus 0.4375 t square minus 2.19 t, and this will become minus 2.5875, and if I bring this to the other side of equation, so that will become plus 6.25. So this is minus 2.5875 plus 6.25, and this gives us 3.66. So this gives me, both of these gives me 3.66. So this is, so this is the s of t equations for the second interval. So now we want to find the total distance traveled from when t equals to 8 seconds. So we have to put t equals to 8 seconds in this equation. So that will be s equals to 0.0208 into 8 to the power 3, 0.4375 8 square minus into 8 plus 3.66. This is 6625. So this is 6625. So this will give us the total distance traveled from 0 to 8 seconds. So this gives me 24.7921. So this is approximately 24.79 meter. So this is the total distance traveled by that safe for when it travels the distance for 8 seconds. So, right, so this is that final answer. And the velocity when t equals to 8 seconds is, we have determined that velocity here, which is 8.81. so the velocity is, after 8 seconds, the velocity is 8.81 meter per second, and the distance traveled after 8 seconds is 24.79 meter. So this is the solution of this particular problem. I hope this will help you in your learning. Do subscribe my channel if you haven't done it yet.